Namaste and welcome to Apna Gurukul Maths. Today we are starting a brand new chapter of class ninth, chapter number 7, triangles. This is a very amazing chapter. There's a lot to learn from this chapter, and this chapter is one of my favorites. So let us begin. So we'll start with what is a triangle, obviously. So what's a triangle? Polygon with three line segments. Now, uh, what is a polygon? I guess I need not explain that. Polygon is any two-dimensional, or I would rather say any shape which is drawn from straight lines. It's a closed and simple figure. I hope that is clear. Simple closed curve which is made up of straight lines, that's called a polygon. If it has three line segment, it's called a triangle. Polygon has also three vertices, three angles, and three sides. I hope that makes sense. So what is the focus of study in this chapter? In this chapter, we are focusing right now on congruence of triangles, rules of congruence, inequalities of a triangle. Now, all these three properties we have already verified in some way or the other in our previous classes. That is class 7th or 8th, but we have never proved it. So over here, our main focus will be how to prove them and where do we use it, right? So let us try to understand congruence of triangle. What is the need to study? Okay, we will try to understand with the example of refill and pens. Suppose you have pen, as you can see over here. I have all different variety of pens, and over here, suppose you have this what to name pentonic pen. It has got a refill, right? And I guess it's use and throw. Okay, suppose you have a pen which has refills, and that refill gets over, and you have to put a different refill altogether. Now, if you don't get the same size and shape of the refill, will you able to use that pen once again? No, right? Then the company who is manufacturing, the company which is manufacturing this pen and the refill must be very, very precise in calculating the size and shape of the refill. How much quantity of ink they have to put? Yes or no? That is where the rule of congruence comes in. Same shape and same size of the refill. That's one example. Second example could be we eat a lot of ice creams, right? Can the stick ice creams, we eat cone ice creams. Now, have you observed all these? Suppose you are talking about the cone cornetto being my one of my favorites. Cornetto ice cream, if you are talking about, have you observed that every cornetto ice cream, if you are purchasing it of 35 rupees, every 35 rupees ice cream of that company would be of same shape and size, no matter where you purchase in India? To make that, we need the idea of congruence of triangle. Same goes with the candy ice creams. Now suppose we are building, we have a building. Now suppose whatever building you are living in, it is made up of lot of congruent bricks. If the bricks are not congruent, then the shape of building is all damaged. So as I showed you three different variety of examples where congruence is used. Now these are not the only things where congruence is used. There are means many different places where congruence is used. Now the obvious question arises: why are we focused on congruence of triangles? Triangles is one of the most popular shapes when it comes to constructions, and congruence of triangles, since this is the polygon which has minimal sides. Any polygon cannot have less than three sides, right? So that is how we are starting to learn about congruence. Congruence as a field of study, it's very huge field of study. Congruence is used even in 3D shapes, but right now, as a beginning, we are starting with triangles. I hope that makes sense. So let's understand congruence, what we mean by congruence. So when we talk about congruence, as you can observe, I have two triangles over here, A, B, C. Now if I try to keep these shapes on one above each other, one above the other, so do they overlap? I took JK, JK, L, on ABE. Now I'll do the other way around. So do they overlap each other? Absolutely. So if two triangles are able to overlap each other, then they are said to be congruent. Or you can also define it as like same shape and same size. Now to tell that two or more triangles are congruent, we must be knowing that it has same shape and size. How will we determine that a triangle has same shape and size? For that, we have different categories and criteria. We will try to first understand with the help of simulations, and then we will go for axioms and theorems. So let's suppose we have a criteria where all the three sides are same. As you can observe, the red side is 5 centimeter, the green side is 3, and the violet is 7. Now over here I'm trying to make a figure which has these three, a triangle which has these three shapes. These three length of sides. Now when I make the triangle, when the triangle is complete, do you observe that it has exactly the same shape and same size? That means if we have three pair of sides being equal in two different triangles, then they are said to be congruent. This is one criteria. Now suppose we are talking about angles being equal. Over here, as you can observe, 30 degree, 30 degree, 100 degree, 100 degree, 50 degree, 50 degree. Can we be so sure that both the triangles will always be congruent? Let me see. Let us see. Now what did I do? The angles are still same, but the size are different. Clearly, as you can observe, the triangle on the right hand side is way bigger than the triangle on the left hand side, right? That is very, very clearly stating for us that they are not congruent. So we cannot use AAA criteria to prove that two triangles are congruent. As you can see, even I made them very, very smaller, almost half the size. The angle remained the same, but the sides have different lengths. Let us move on with another criteria. Now I have SAS criteria. Now observe, what do we mean? Why do we write it as SAS? Side angle side. That means the angle which is made is included by the two sides. It is made by the 3 centimeter and 7.3 centimeter. These two sides. It is nowhere to deal with the third side. As you observe, it's exactly the same thing over here as well. Now, if I try to make the triangle, there is only one possibility of triangle, right? That means this criteria can also be used as a congruent. Now, obvious thought comes, what if instead of SAS, now the angle is not included in the two sides or not made by the two equal sides? Will that be used as a congruence criteria? Let us try to experiment that. Now over here, as you can observe, 6 and 11 are different. Now in the previous case, the angle should be made over here by 6 and 11. But right now, it is made by 11 and 13. 11 and the third side. Now let us try to observe. This is one possibility of the second triangle. If this is the possibility, then it is congruent. But now observe my difference. Even now we can see a triangle, right? Is this anywhere congruent to this particular triangle? The left hand side? Absolutely not. That is why SSA criteria is never used, and I showed you with one example. Okay, now I've already stated in one of the videos that in mathematics, if we have to prove that something is true, we have to prove for all possible scenarios. But if we have to prove that something is not true, we just need one counter example. We showed one counter example over here. With same measurements, if the angle is not included in those two equal sides, I have possibility of two different triangles. Now two triangles cannot be congruent to the same triangle, right? So over here we have the counter example. Let's understand about the next criteria, that is RHS, or it is also called as height and length criteria, or it is called as RHS, right angle hypotenuse, and H means one of the sides. I have 190 degree, one of the sides 6 centimeter is equal, and the hypotenuse is equal. As we make the triangle, now it is an open figure. I am making a triangle. As I made the figure, as you can observe, it is exactly congruent to each other. That is another criteria. Let's try to observe what happens when we have two angles equal and one of the sides are equal. So as you can observe, ASA, that means the side which is equal is between those two angles. As you can observe, 35 and 65, 7. So in this case, as you can observe very clearly, now I'm not showing you by overlapping because it's very clearly evident that they are congruent to each other. That means they are in equal shape and size. Now, this one is really amazing. What if we have AAS criteria? That means two angles and any one of the side is equal. So in this case as well, we will be getting a congruent shape. In the previous time, SAS is possible, but SSA is not possible. But in this criteria, ASA is also possible, AASB or AAS is also possible. What is the reason? Because once the two angles of the side are equal, the third side must be equal, because the three angles must add up to 180 degrees, which we have already studied in the chapter lines and angles. But in case of the sides, that's not the case, because for sides there is no limitation that triangles three sides must add up to this many centimeters. That is never a criteria, right? So that is why it is it is said that AAS is also a true criteria. Now, there is one thing very much important when it comes to congruence. We must be careful about the corresponding parts. Now, what is the corresponding part? Let us try to understand first. Now, when I try to overlap the triangle JKL and ABE, as you observe, the side JK is equal to side AB, side KL is equal to side BE, and AE is equal to JL. Yes or no? Yes or no? So this particular thing is called as corresponding parts. AB is corresponding to JK, BE is corresponding to KL, and AE is corresponding to JL. Similarly, angle K is corresponding to angle B, angle J is corresponding to angle A, angle L is corresponding to angle E. So there are total of 6 corresponding parts in a particular means in two congruent triangles, right? Now, as we have observed, out of these 6 corresponding parts possible, if we are able to show a combination of 3 corresponding parts, that side that we just now saw, side angle angle, RHS, or angle side. These 5 criteria are 5, right? SSS, SAS, AS, ASA, and RHS. These 5 criteria, these 5 combination of 3 corresponding parts, if we are able to show, then we can show that the triangles are congruent to each other. Now, my dear friends, observe. What happens if I don't keep the corresponding parts together? Will the triangles be still congruent? I will. Now, as we discussed, J is corresponding to L. Now, I'm not keeping J to L. I'm matching A to K. Is it overlapping right now? No, right? Let us try to observe a little differently. Now, I'll put A on L, and now try to make it overlap. Am I able to overlap in any manner? No, right? So there is only one possibility of overlap when the corresponding parts are kept together. Now, as soon as I keep A at J and try to keep all the corresponding parts on each other, the two triangles overlap. That is why when we talk about congruence, corresponding parts plays a very vital role in deciding the congruent triangles. I hope that makes sense. So that is how we discuss the criteria of congruence. Now let us move on to axioms and theorems related to criteria of congruence. So first axiom what we have is axiom 7.1, which says SAS congruence rule. Now, why is it an axiom? Because we cannot prove it with the help of previous known axioms or postulates or theorems. That is why it is taken as an axiom. So what does it say? Two triangles are congruent if two sides of the included angle of one triangle are equal to the two sides of the included angle of the other triangle. Suppose I have two triangles over, means one triangle. Now let me explain what is the included side. I've already explained it, but let's discuss. ABC. Now if I talk about AB and AC as the corresponding sides of the other triangle which I have not drawn, then angle A will be the included side. AB and AC makes angle A, so angle A will be included side of AB and AC. I hope that makes sense. So our congruent, if two sides and the included angle of one triangle, this is the one triangle. If I draw another triangle, let's name it as DEF, and if AB is equal to DE, AC is equals to DF, and if and only if angle A equals D, then we can say ABC is congruent to DEF. If angle A is equal to angle E, we cannot use the SAS criteria because angle E is not included by the sides DE and DF. I hope that makes sense, and that makes the congruence criteria for SAS. Now let us do two examples related to that. Example number one. It says that figure 7.1, it is exactly taken from the textbook. That is why it looks like this. So um, I'm not so sorry, but yeah, I'm just saying, yeah. So figure OA is equals to OB. Now OA is given to be equal to OB, sorry, and OD is given to be equal to OD. Yeah, show that triangle AOD is congruent to triangle BOC. Now how to write these answers, you can go and refer the textbook. When I discuss about the exercise problem, I will discuss about this once again, so please don't worry about that. Means discuss in detail how to write the answer, but for now let us quickly understand. We have to prove these two triangles are congruent. Now what is the meaning of that? Angle A will be congruent to angle B of the corresponding to angle B of the other triangle. Angle O will be corresponding to angle O. Angle D will be corresponding to angle C. That is what it represents. Okay, so now when this representation is clear, let us try to understand. Since we are considering AOD and BOC, so AOD, that is this particular triangle, and BOC, that is this particular triangle. Over here, OC is equal to OD, AO is equals to OB, and the third thing which we can observe, BOC angle. Now these two criteria, these two sides are already given to be equal. Now we just have to find one more criteria, the angle. Now these two sides make this angle, and AO and OD makes this triangle. Now this angle, sorry. Now these two angles, that is BOC, angle BOC is equal to angle AOD. How are they equal? Vertically opposite angle. We know already by vertically opposite angle axiom that vertically opposite angles are always equal. So that is how we have the two angles as equal. So what do we get? SAS criteria. We can say that AOD is congruent to BOC. I hope that makes sense. Now, so we have proven that congruence criteria by SAS because two sides are already given, angle we have shown by vertically opposite. Now we have to prove AD is parallel to BC. We have to prove AD is parallel to BC. Now if we somehow prove that these two angles, that is CBO, I will name it as angle X, is equals to OAD, that is angle Y, I'll name it as. If they are equal, that is alternate interior angle. So alternate interior angle, if they are equal, then what does the converse of alternate angle axiom says? That if two angles are two alternate interior angles are equal, then they will be parallel. The lines will be parallel, which are making those alternate interior angles. So we are using that. So now from the triangle, from the congruence criteria, we know one property CPCT, which I showed with the figure as well. CPCT means corresponding parts of congruent triangles. I'll repeat, corresponding parts of congruent triangles are equal. So what do we mean by corresponding parts? Once we have proven that the two triangles are congruent. Now, how many parts corresponding parts we discussed? 6 corresponding parts. If we are using the SAS criteria, we have used 3 of them. Now, once we have proven that they are congruent, the other 3 remaining, that is 2 angles and 1 side, the other 3 remaining corresponding parts will also become equal. That is what CPCT says. I'll repeat. To prove that these 2 triangles are congruent, we have used 3 corresponding parts. And we know that 2 different triangles will have 6 corresponding parts. We have already shown 3 corresponding parts. So we are remaining with 3. Now since we have used 2 sides and 1 angle, we are still remaining with 2 angles and 1 sides. After we have proved that those 2 triangles are congruent, the 3 remaining corresponding parts easily become equal without any doubt. I hope that is very much clear. So now we need to show that CBO is equal to OAC. So CBO, as you can see, B is over here and A is over here. So they are corresponding parts. So angle CBO will be equal to DAO. Why are they equal? CPCT rule. That is, corresponding parts of congruent triangle are equal. Now since alternate interior angles are equal, we have proved AD is congruent to BC. Now I'm not writing the complete answer for this because this is example 1. When you open your book, it's the same answer is written exactly. Once we discuss the exercise problem, we will discuss the answers as well in detail of a few questions. I hope this is clear. Let us move to example number 2. Now this says that AB is a line segment. This is a line segment and line L is its perpendicular bisector. What is the meaning of perpendicular bisector? It is making a 90 degree. Bisector means C is the midpoint. That means AC is equals to CB. If point P lies on L, that means the line L, which is the perpendicular bisector, we need to show that P is equidistant from A and B. That means we have to show that PA is equals to PB. BP or PB we have to. So we have to prove that. Then if we have shown that, that means P is at equal distance from A and B. So how do we proceed? We will take 2 triangles. In triangle PAC and PBC, we already know AC is equals BC because this is given criteria, and angle PCA is equals angle PCB, that is 90 degrees. Yes or no? And then similarly we can show we can see that PC is equals to PC because this is the common side in both the triangles we have considered. Common side. That implies that triangle PAC is congruent to. Now while we are writing the name of congruence, we need to focus on corresponding parts. So PA, as you can observe, PA is corresponding to PB. We cannot say that because that is what we have to prove. So now we will look at the other part, AC. AC, as you can observe, is corresponding to BC. And angle C is equal to angle C, means they are on both sides angle C are equal, right? So that is why C is at the same place. So angle PAC will be congruent to PBC. That is how we measure, find out the congruent parts. Okay. So now we have shown that they are congruent. So can you say that PA equals PB? Because PA and PB are at the same positions in the congruent we have written, right? So since they are at the same positions, we can use the CPCT rule, corresponding parts of congruent triangles. That is how we get that triangle PAC is congruent to triangle PBC. I hope that makes sense. So let us now go to Theorem 7.1. Now we have already read about axiom 7.1. Let's move on to theorem 7.1. This is talking about ASA rule, that is angle side angle. Between the two angles, the third side is equal. Now, true triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. Now, my dear friends, always remember that when we are talking about the congruence, we always have two triangles, because congruence is a type of comparison between the two triangles, and comparison cannot happen with only one triangle, right? So that is why we need to have two different triangles. I hope that makes sense. So AAS congruence rule is so that is how we get ASA criteria. Now AAS rule, as we saw in the simulation before, AAS congruence rule is also true. Why? Because when we have two angles equal, the third angle automatically becomes equal. So AAS rule is a default rule of ASA. Okay, we can also say that. So what is the meaning of AAS rule? Two triangles are congruent if any two pair of angles and one pair of corresponding sides are equal. Corresponding sides is very, very much important. So related to this theorem, let us try to do one simple problem. Now, as you can observe, line AB is parallel. Now, here the parallel is given. Parallel is parallel to CD, another line segment CD. O is the midpoint of AD. That means O is the midpoint of AD. That means AO is equal to OD. Now, we need to show that AOB is congruent and then O is the midpoint of BC. So, if we are able to show that they are congruent, midpoint part we can, for midpoint, what do we need to show? OC is equal to OB. To show that, what do we need to if we have proven that they are congruent by CPCT, we can easily say that the two sides are congruent. Perfect. Now, since AB is given to be parallel to CD, if I take AD as the transversal, what can you talk about angle CDO and OAB? They are equal because they are alternate interior angles. So I'll name it as angle A and angle A. And what can you say about angle DOC and AOB? They are vertically opposite angle. So two angles are equal. Right now we have proven with the given conditions. And OA, which is the side, is equal to OD already. So angle, side, angle. I'll name this one a vertically opposite angles as X and X. So angle, side, angle criteria. We have proven that triangle AOB is congruent to triangle DOC. Once we have proven that they are equal, as we can very easily say, OC and OB are corresponding parts. Why are they corresponding parts? As you can see, they are the incongruence criteria. OB is the last and OC is also written at the end, right? So they are the corresponding parts. Okay, so that implies that OC equals OB. So O is obviously the midpoint, because if OC and OB are equal, O must be the midpoint of BC. That's how we prove it. Now, if you have got doubt, how am I writing the corresponding parts? Please take a look. If it is given as triangle AOB is congruent to triangle DOC, what is the meaning of that? Means how do we represent the corresponding parts? First thing, angle A will be corresponding to angle D. Corresponding is written by this symbol. Angle O will be corresponding to angle O. Now, it might look a little bit ridiculous type, but how can it's very much similar? But that is why we represent it by three vertices. So if I try to modify this and write, angle AOB is corresponding to angle DOC. Similarly, angle B is corresponding to angle C. So these are the three angles which are equal. Now let us try to three angles which are corresponding. Let us try to see about the sides which are corresponding. AO is corresponding to DO. Then OB, which are the two farther ends. So OB is corresponding to OC. And then finally, AB is corresponding to DC. AB is corresponding to DC. Yes. Now, as I told you earlier, that any three we require to prove it as congruent. So over here, which of the three we have used? Angle D and angle A, we showed it as equal. So this one we used. AOB and DOC we used as vertically opposite angle, and side OA and OD we used as OA and OD. These three we used it to prove that AOB is congruent to DOC. The other three, which are, I'll shade it by green. So angle B is congruent to corresponding to angle C, OB is corresponding to OC, and AB is corresponding to DC. These three becomes automatically equal because of the CPCT rule, corresponding parts of congruent triangle. I hope that makes a lot of sense. So with this, we are done with this first video of ours. So we have understood the importance of congruence. We have understood where do we use the congruence, why do we need to study about this, and we have used two different congruence rules, and we have solved a few problems. That is it for this video. In the next coming video, we will try to explore some different criterias of congruence and some more related concepts to that. Thank you so much for being with us. See you in the next video. Until then, keep smiling. Jai Hind. If you find it useful and would like to share with your friends, please do share this video so that many of your friends can get a help of this particular topic, because I'll be making the topics videos on each and every topics here on, as well as the exercise problem. See you in the next video. Keep smiling. Jai Hind once again.